Yeah, so I was trying to make a really over-the-top intro. The problem with that is I don't know how to edit that good. So I guess this is the intro you're gonna have to live with. Anyways, enjoy! Today we are gonna go through some logical units in geometry. Now, why are we doing this? That's a very good question. I just think it's fun or something. So yeah, we're basically gonna be doing these circuits. Yeah, let's get into it. So now we're here in a separate level. We're gonna be doing everything from scratch, just to make it easier to follow with the tutorial or something. So the reason why I'm making this is because I want to make a general purpose computer in geometry, one that is very similar to what MatBat did in Minecraft with his general purpose computer that can basically run any custom code. That's basically what I want to do, but in geometry. Now, the difference between what I'm trying to make and something like Gphone Dash is that Gphone Dash has more of like a preset display, basically making it so that it can't really run custom code. It has its code that it runs on, and that's it. It is very versatile, yes, but everything is technically a preset. So what I want to do is just make a computer that doesn't need that preset. It just gets code that it then runs and displays on a custom display. So first of all, these two are the gods of computer science in geometry. That's all I can say. This one is the one I've used the most in more advanced circuits like the half adder and full adder. But today we're just going to be focusing on the different logical circuits. First of all, this is the main thing that's going to be doing the displaying the counting and everything. So this is what's going to be read and changed. It's an item that will have an ID. We're just going to make it 1. Now, the item ID is separate from the group ID. That's important to know. So basically, we want 2 inputs. This is the first input, this is the second input. And then we're gonna have the output. All these have to be separate groups, item IDs, I mean, so that this one, if this changes, then this one doesn't change or something weird like that. Now, this result one is gonna change depending on what these two are. So we're gonna go and make the first, most simple logical unit, the OR gate. So first of all, the first thing we want to do is to make these inputs display in binary. Now, I know that the computer is most probably going to run completely on base 10 or something like that, but just to make it more simple and easy to understand, I'm just going to start in binary, both for myself and for you guys watching. So the switches, if you say so, are always going to be spawn triggers, and we're going to make them touch and multi-trigger, so you can go through it and touch it and okay, pause. You can interact with it. So yeah, about we're gonna give it the group ID 1, so it will only affect the first group. we'll do the same with this one and give it a separate group. Now this one, just because it has group ID 1 does not mean it directly interacts with this one, because it has item ID 1. Now remember, item and group ID are separate things. If we were like this, then it would happen, but nothing would really happen because a spawn trigger can't really do anything with this one. So what we're gonna do is make it switch from 0 to 1 every time you go through this one. So the first time you go in or press the button or whatever, you're gonna get a 1. Second time it's gonna be 0. If you go again, it's gonna be 1. So we're gonna use the sequence trigger. Now it is very important that all of these are spawn trigger that we make. Like all of the units that are gonna work like this are all gonna be on spawn trigger. So we're gonna assign group 1 to it, so that when we interact with this one, the sequence object starts running. And we're gonna want 2 new groups for this one. So basically how the sequence trigger works is you give an ID and a count. So the ID is just which group ID will get affected. And it's kind of like a spawn trigger, but better, really. And the count is just how many times this group will be run. We're only going to be keeping it at 1 for the time being. I don't know how it will most probably use it for more complex things. But for now, we're just going to keep it at 1. So we added the group ID 3, and it's going to be done 1 time. So how do we change this item? Well, we're going to need a pickup trigger here. So the pickup trigger basically has an item ID that it affects and then changes the value of it. So in this case, we want it to affect the first item ID. So it's gonna have item ID 1, and because the first time we go in, we want it to switch to a 1 since it's 0 by default. We want the count to be 1. And it's also very important to assign the group, third group, so that this actually does something. And now, as you see, it went immediately. That is because we didn't have the spawn trigger. Now we're also gonna need to have it be multi-trigger, since we're gonna have to be able to switch from 1 and 0 multiple times. So now you see it's 0, but when we enter it, it turns to 1. But it doesn't do anything else. So we're gonna add another group, 4. Now this is why the sequence trigger is very useful, because you don't need just a bunch of spawn triggers that activate each other and activate different groups, and yeah. So now, the first time this is activated, it will activate group 3 1 time. The second time the sequence trigger is activated, it would activate group 4 1 time. Now what do we want the fourth group to do? It's gonna make it a 0. So we're gonna have this pickup trigger have item ID 1 to affect this one. Make sure it's spawn trigger and multi-trigger. Assign the fourth group ID to it. And let's try it. It turns to 1, but nothing happens. Now why is that? That is because we need this thing, the override. So it basically just ignores what is in here and just immediately outputs whatever count we have. You can also put it here. It's not really necessary, but I usually do it. So now you can switch from to a 1 and then to a 0. But there's a problem. If we go one more time, nothing happens. And that is because this sequence trigger only does this sequence once. And that is because of these modes. So the mode stop just goes through it once. Mode loop makes the thing loop. Mode last, I haven't actually tried it. Let's see what it does. But we want this one, the mode loop, so that once this one has been done, it will revert back to the first one. So now you can see we can switch it how many times we want. That is basically how we do input changes. So you can compact it like this. Trigger compacting is going to be a very important thing later on. So now we just do the same for this one. It's the exact same thing, but with other groups. So try doing it yourself without the tutorial. So now we have the two inputs. As I said, they are both the same, but nothing is happening to the result. And that's because, well, nothing is interacting with it. This is where we're gonna need one of the gods, the item ID, the item edit. So this one looks very scary, but it's not, trust me. So basically it takes in two different item IDs, then does something, and then outputs it in another item ID. So basically it's like a calculator type of thing. So what we want to do is have the first item to be 1, because we want both 1 and 2 to be the items we want to compare or do something with. So we have these two, item ID 1 and 2, and make sure that they are both checkmarked as item, so that they work, because there are a bunch of things you can do here that changes the way it works. Now the target ID is 3, because this is going to be the result. So as you can see now, we have display. The third item ID is equal to the first one plus the second one. Now if we try this, we see that nothing really happens. That is because we don't have it on spawn trigger. It runs once and that's it. But even if we do have it on spawn and multi-trigger, there's nothing to activate it. This is where we're gonna need a spawn loop. So how do we make that? It's very simple actually. You only need 3 spawn triggers. So what you're gonna do is have a spawn trigger. We need a new ID. It's gonna be 7. So this one is not gonna be spawn trigger. It's gonna start immediately when the level starts. It's gonna affect this one. So this is gonna have 7. This spawn trigger. Now this one is gonna need a new one. It's gonna target group ID 8. This one has to be spawn trigger and multi-trigger for the loop to work. So this spawn trigger is gonna activate this one. So this has to have group ID 8. Now to make this a loop, we can make this one activate group 7, which is this one. And make sure it's spawn trigger and multi-trigger. And now we can just assign 7 and 8 to this one. So now this is also getting activated by these ones. this spawn trigger is activating this spawn trigger as well as this one. And then there's a loop. We can call this a global loop. It's basically just the loop that you'll be using for everything. Now you probably won't need. You're probably not gonna use the global loop to everything in a actual computer. You're probably gonna have some closed loops or whatever as well. We can also label these as input A and input B. So now, as the loop is running, this one should be going on all the time because spawn trigger and multi trigger and is in the loop. So let's see. Yeah, it doesn't work. Now, why is that? Well, it has to do with the loop. It is kind of broken. And it's because there's no delay. This is a very important slider. So basically, they are trying to activate each other instantly, which doesn't really work. So we need a delay, but we can't just put something like that. It might look like it will work, but it is still too fast. The fastest we can have is 0.01. We're gonna have to put it on both of these. Now, when we start, we see it's 1, 2, 1, 0. But that's not what we want. We want it to be an OR gate. So when this one is on, it's gonna be 1. If this one is on, it's gonna be 1. If both are on, it's still gonna be 1. Now it's a pretty simple gate, but believe it or not, the equation is more complicated than, for example, an AND gate. So how do we do this? Well, it's kind of hard to explain. We're gonna use this modifier and putting up to 2. So now you can see that 1 plus 2 is getting times by 2. We don't want that. We want it to be divided by 2. And this is a little funny because this is an AND gate. If we go check it out, we can see when both are on, it becomes 1. So that is an AND gate, but we want an OR gate. So to make this to an OR gate, we go over to this button, which has round, flare, I guess. I don't really know what this is, and ceiling. So the ceiling, what it basically does is take a float, so basically a 1.2 or 32.1, and then makes it the closest integer. So 1, 2, 3, yeah. That is equal to or greater than that float. So 1.1, the ceiling of 1.1 would be 2, and the ceiling of 3 would just be 3. So basically what it does, it takes input 1 and 2, divides it by 2, and then takes the ceiling of that equation. So if we only have 1 on, we have 1 plus 0, it's 1 divided by 2, which makes 0.5, and the ceiling of 0.5 is 1, because 1 is the closest integer that is equal to or greater than 0.5. And if we have both on, we have 1 plus 1, which is 2, divided by 2, it's 1, and the ceiling of 1 is just 1, because it's already an integer. So if we go here, we can see that it works amazingly. So that's how you make an OR gate. Let's go on to the next gate. Now I already told you about how to make an AND gate. You just have item ID 1 plus 2 divided by 2, and that is going to be 3. The item ID trigger only takes whole integers and doesn't really care about decimals. So if it's 1.1, it's just gonna be 1. And if it's 0.9, it's gonna be 0. It just removes the decimals completely. So now it's an AND gate. Now I'm not gonna make this into a separate gate like that, because it's just gonna take a lot of time. Just know that making an AND gate and OR gate are basically the same. You just need to change this one. So let's go on to something a little more exciting. Alright, so we're doing the XOR gate next. So the XOR gate is a little bit different. It does not use the item ID. It uses the other god, the compare ID. The item compare. This is item edit, not ID in my days. So how we're gonna be able to make these two XOR each other. Now if you don't know what XOR is, it's exclusive. It stands for exclusive OR. So basically an OR gate, but only one of these can be 1. If this is 1, this is 0, then this is 1. If both are 1, then it's a 0. So what do we want to do with this compare ID? Now, as you can see, the compare ID, look, the item compare, oh my days, the item compare trigger looks pretty similar, but it has another modifier, a true and false ID, a little less buttons, I think. So first of all, we're gonna make this a part of the loop so that it runs all the time. It always compares these two. Make it 7 and 8, so now it runs all the time. So basically, the first thing we want to do is compare if 1 is equal to 1. Now we can compare the items a little differently, but the easiest way and probably the most intuitive way is to just go one by one. So check if item ID 1 is 1. If it is, then we check if ID 2 is 1. If it isn't, then we make 3 1. If it is, then we just keep it at 0. So how do we do that? Well, we first put in item ID 1 here. So as you can see, it now checks if item 1 is equal to 1. Now this is some programming syntax, if you say so. If there are 2 equal signs, it will check if 2 values are the same. Now we don't need this one, because we just don't. If we were to use it as an item, then it would replace the 1 here. But we don't need that right now. So if item ID 1 is equal to 1, then the true ID will go. If item 1 isn't equal to 1, then the false will go. So let's see, if item ID 1 is equal to 1, we want an ID to go off, not 8, 9. If that is true, then we check if the second item is 1, just the same thing. We just have the 2 here, and you can see here that item 2 is equal to 1 if it is. Now it's important to make spawn trigger and multi-trigger. Now this compare is one that we don't want to loop. We only want this compare to go when this thing is true. So that means we're only gonna have it be item ID 9. So now if item 1 is equal to 1, the group 9 will run, which is this one, and it will check if 2 is equal to 1. If it is, then we're gonna have 10 to run. And what is this going to be? Of course, it's going to be a pickup trigger, because pickup triggers are the only ones that can, if you say, edit the state of items, as far as I know. So we want this pickup trigger to affect item ID 3. Like this. I usually structure it like this, so we have the true ID to the left and the false ID to the right. If you do these kinds of things, then you can basically see the item compare as an if statement, kind of, if you know programming. So we have if item ID 1 is equal to 1, item ID 3, the pickup group 10 will go. So what we'll do, well, because both of them are 1, it's going to be 0. So override spawn multi-trigger. Now you might think we don't need this, but I'm going to explain why we actually need this a little later. So let's go back to this one. This is run if item ID 1 is equal to 1. So if item ID 1 is not if item 2 isn't equal to 1, then we want group 11 to go. So I'm just going to copy this one over, make it group 11. So if item 1 is equal to 1 and item 2 is equal to 0, then item 3 will be 1, because that's how the thing works. Let's try it. Perfect. But then there's this problem, and we're gonna fix it. We're also gonna try doing this. Yeah, you can see that. So it's gonna be fixed with the next compare. So we go back to this first one. If item ID isn't 1, then we have group 12 start. So we make another item compare, and this one is going to be the same as this one. So if item 2 is equal to 1, then we want 13 to go, and if not, 14. So if 1 is equal to 0 and 2 is equal to 1, 3 is going to be 1. That's how the XOR works. So it's going to be 13. Did I did not. Yeah, we have to add the false ID of group ID to this one as well. So there we have that. And if it isn't 1, then we're gonna have group 3 to just be 0. 14, I think. Yeah. So that is how you make the XOR. If we can look, we see here, and it works like a charm. And that is the reason why we need these zeros, because first both of are 0, so this one's false and this one's false, so it's 0 added, even though it is already 0 from the start. That's getting a 0 all the time. If I now make this 1, then this one's true, so this one's 1, this one's 0, then it goes to this one, which makes it 1. If we now were to turn off this one and this weren't here, then we would have 0, 0, and nothing. So if we remove this one, we see that the one would just be left there. So that's why we need the zeros. Now we're gonna get into the NOT gate. So basically, the NOT gate is just the negated version of the input. So if this is 1, this is going to be 0. If this is 0, it's going to be 1. The output is going to be the reverse of the input. So how do we do this? Well, we're going to need the item compare trigger. And we're only going to be using 1 this time. And it's a little bit different from how we have made the others. Now we're going to compare these two. So how we're gonna compare them to make the not gate work? We're gonna see if they are the same. So let's first implement them into the loop. There we go. So now the item compare checks if 1 is equal to 2 all the time. Now because this is a NOT gate, we don't want them to be equal to 1. So how do we change that? If we look at this, we can make the true ID. So if 1 is equal to 2, then run the 9th ID. So let's add a pickup trigger with 9 that changes the count to 1. And let's see how that goes. It works. 0 and 1. But now it doesn't. And you might think, well, can't we just make a false ID and then give that false ID to this one and make it 0? Well, yeah, we got a little problem. That is because we have 1 is equal to 2. When it is, number 9, group 9 goes, which turns into a 1. And then 1 isn't equal to 2 anymore. So the false ID runs, which turns it into 0. And we get a loop. So that's not gonna work. Then how are we gonna make it work? We're gonna treat this one as an input, but just a little different. And what are the main parts of an input? Well, it's the sequence trigger. That's the thing that makes an input work. So let's add a sequence trigger that is triggered by the true ID. So now the sequence trigger is triggered. So let's make this a loop so that it doesn't stop, and spawn trigger. So we're now gonna treat it as an input. So basically make the same thing. A new group, 2 of them. So 10 one time and then 11 one time. The first thing we want to do, if we look at this, 1 is equal to 2. Then the sequence runs, and it runs the 10th one, which we can make this one. And we don't want them to be the same. So this can just stay the same. And it works the same. But if we now try, nothing's gonna happen again. We're gonna have to add another pickup trigger, just like the input. Make it 0 and change the group to the second in the sequence. And now, as you can see, the NOT gate works. That is because this one loops. It checks if 1 is equal to 2. If it is, run this one, which runs the first one. Make it 1. Now they are no longer the same, which means this one isn't getting run. When you flip this one, it becomes 1. And this is also 1. So then this is true, which sets the sequence. And because it's already run the 10th group, it runs the 11th group, which turns to 0. It's pretty simple. Alright, so here I have all of the units we've gone through, OR, AND, NOT, and XOR. But we also have the negated versions of those, XNOR, NOR, NAND. We can look at how these work. It's basically just inversing it. So it is 1. It is 1 all the time, but turns to 0 only when one of the inputs are 1. It's pretty self-explanatory. It's just the negated version of the normal. Yeah. This one doesn't work. It works with this one, but not with this one. Okay, I gotta change that. I'm gonna change the NAND a little bit. I'm not gonna do it right here, but this level is gonna be the level ID is gonna be in the description, so you can check this out. But you can see the layout of the negated versions. I want you to try to make them yourself, and of course there is the answers are of course here in the level if you get stuck, so make sure to just read through them. Read through them and really try to understand everything that is happening. So when you see this 99, all of these sequences that has a sequence and then pickups to either side of them are almost always inputs. Not in this particular case. As you can see, I've made it pretty organized. So we have the main component, input, the two different, you can see here is a main component and the inputs. So in that way I have organized the circuits. You can also go here, get the ship, and try these ones that we've already gone through. Yeah, so anyways, that's gonna be it for this video. If you are interested in like computer science, in Geometry Dash, then I would probably recommend to join our Discord server. Not right now when I'm uploading this, because there are basically no people online, but I really hope that it becomes like a little bigger community over the years. But you can help become that community if you want to, if you find this interesting. If you don't really know where to go, I'm gonna be keep uploading tutorials and stuff. But you should also check out, if you don't know anything about computer science in general, then you should check out MathBatWing's Logical Redstone Reloaded series. That is in Minecraft, but he still goes through all the logic behind computer science. So I would recommend watching that and trying to apply what you learn in Geometry Dash. So then you can just use these triggers and everything, do your problem solving and do animations and stuff. Yeah. Anyways, I think that's just gonna be it for today. Thank you guys so much for watching. I'll see you in the next one. Peace.